This is problem number 7 from section 1.6. In this problem it says, solve for y in terms of x. So they want us to get y by itself. So it says y equals some expression on the right side. Now you'll notice we have numerous logarithms here. So we're going to have to use our log laws to combine some stuff together before we can get y outside of this natural log, because it's on the inside right now, so we're going to get rid of the natural log so that it's on the outside and we can actually get y equals. The first law we're going to start with is the quotient rule for the log laws. We have the subtraction law. You can see we have a natural log minus another natural log. Anytime we take the logarithms of same base and we subtract, we can take them and combine them to one logarithm with a division. So we're going to write this as natural log of 1, so it's just one logarithm of y minus 8 over what's on the inside here, which is 5. So we combine these two together to give us one logarithm. Now what I want to do is I want to bring this logarithm to the other side and use the same rule. So if I subtract this to this side, now I have natural log of y minus 8 over 5 minus natural log x equal x. And you'll notice I'm in the same situation that I was at the beginning. I can now use this subtractive quotient rule law where I take this logarithm minus another logarithm of the same base and I can write it as a fraction and just one logarithm. So really how this is going to look is I would say natural log of y minus 8 over 5 over x equals x. But when I take a fraction, I divide another number with it. That number just ends up with going into the denominator of this fraction. So this x is going to end up in the denominator of the fraction. And you could see that if I write this up here a little bit. Maybe I'll just write it out for you. So you have y minus 8 over 5. When you're dividing by x, remember x is just it's technically an unknown number, but it's like a whole number. We can write it over 1. So when you have a fraction divided by a fraction, you end up taking y minus 8 over 5, which was the top, so this equals y minus 8 over 5, times the reciprocal of the bottom, which is 1 over x. And you can see you end up with y minus 8 over 5x. So there's two ways to think about it. I have a fraction divided by a fraction, I flip and multiply, and I end up with 5x in the denominator. Or I have y minus 8 divided by 5 divided by x, so total I divided by 5x. Those are probably the two ways to think about that. So I'm going to write that as natural log y minus 8 over 5x equals x. Now at this point I want to use a cancellation law, and I'm going to use this log law that says if I take whatever the base is for my logarithm and I make it the base for an exponential, they're going to cancel each other out. So my base for my logarithm is e, so I'm going to say e to the natural log of y minus 8 over 5x is going to equal, and I have to do it to the right side too, e to the x. This cancels, leaving you with y minus 8 over 5x equals e to the x. Now at this point, we don't really need any more laws. We just need to multiply each side by 5x. So I'm going to times each side by 5x. And when I do that, it cancels this 5x, leaving you with y minus 8. And then you end up with equals 5x e to the x on the right side when you take 5x times e to the x. Last step, I add the 8 over, and I end up with y equals 5x e to the x plus 8. And so I've just solved for y in terms of x here. So now if I know the x value, I can immediately get the y value.